Hey my friends, it's your friendly neighborhood headless, faceless teacher coming at you again to help you more with some proof. This time we're going to look at angle and segment kind of proofs with our segment addition postulate, our angle addition postulate, and some other things we've learned in the last chapter. So let's get started with this example. In this example we've got a segment divided into parts with point B between A and C, and we're given that point B is actually the midpoint of segment AC. We're asked to prove that the distance from A to B is 12. Now I know you probably have some of these already filled out in your packet, but I'm going to just uncover it one line at a time so we can focus on the line we're looking at. So our first statement, like very often is the case, is going to be that statement, just a restatement of what is given. We're given that B is the midpoint of segment AC, and so that's what even our reason for that. We're given it, it's true. So what does it mean to be a midpoint? You remember a midpoint is the dead center middle, and exactly two pieces of that segment are a match. Those are two congruent parts. So we're going to write that in our proof that we've got two individual pieces. And so our next line, let's say that the distance from A to B is equal to the distance from B to C. And how do we know that? Well, because B is the midpoint. So we say definition of midpoint. Now notice up here, in the line previous, we mentioned that we had a midpoint, and so that allowed us to then use the definition as a justification for another statement. That happens a lot. All right, well, if A and B, or excuse me, if A to B is the same as the distance from B to C, then let's make some substitutions with the values. And this is the same way you solved these when we solved these before. So our next line is that 6x is equal to 2x plus 8. Now where does that come from? 6x here in the picture is the same thing as AB. And the 2x plus 8 in the picture, that's the same thing as the BC. So what are we doing? We're just changing the statement and we're exchanging it for an algebra expression. What allows us to do that? Well, the exchange property, the thing that allows us to make trades, is called the substitution property. Sometimes we just write that substitution. All right, now let's just work the algebra and list the properties as we get them. So on the first step, we're going to take away 2x from both sides. That's going to bring it down to 4x on the left, and the 2x cancels on the right. And so if we did a subtraction on both sides of equivalent things, that's the subtraction property. And then finally, the last step of our algebra problem is to solve for x. And so we're going to have that the value of x is 2. Well, how did we get 2? We divided both sides by the same thing. We divided both sides by 4. So we use the division property. All right, well, if x is 2, we can refer back to what we were going to prove. A to B is 12. Let's just go back with that 2 and trade it for that x. Another trade just happened. So we're going to plug in the value of 2 for x into the AB expression. AB is now equal to 6 times 2 instead of 6 times x. That 2 is going right in for x. And that 6 times 2 is equal to 12. So our final step was because of the substitution. We substitute it back into the expression. Okay, this one might be just a little bit trickier. We're going to go slow here. Be sure you pause the video and rewind if you need to. We've got a given statement that the measure of angle 1 is equal to the measure of angle 3. And let's go ahead and look at those in our picture. So they're telling us that this angle 1 right here has the same measure as our angle 3 on the other end of this picture. Those two measures are the same, or in other words, these are congruent angles. Our job is to prove that angle AEC, let me highlight angle AAC, that's this angle, AE, and then out through C. We're going to prove that that's congruent to angle DEB. So angle DEB is here, DE, and then out through B. So those two angles that kind of overlap each other. We're going to prove that those are the same size. Well, what statement can we make first? I'm going to guess that we have our given statement under here, since that's a lot of the times that's what we will put. And sure enough, measure of angle 1 is equal to the measure of angle 3. And what would you put for a reason? Of course, that's our given. So the measure of angle 1 and the measure of angle 3 are the same, but those aren't the angles that I want. I want to get the measure of angle AEC, and that's a combination of angle 1 and angle 2 together. And then the same for angle DEB. That's another combination of adding angle 2 and angle 3 together. So let's go ahead and let's do that. Let's add angle 2 to both of those angles that we were starting with. So angle 2 here has been added to both sides. What allows me to add the same thing to both sides? That would be simply the addition property. Just like we do when we're solving an algebraic equation, we're just going to add this angle to both sides. Well, now what did we just say? The name of angle 1 added to angle 2. What's the name of angle 1 plus angle 2? If I add those two together, that's my angle AEC. And the same for angle 3 with angle 2 combined. 3 and 2 combined make angle DEB. So this next statement is going to say just that. Angle 1 combined with angle 2 is our AEC angle. That's our green angle that we've highlighted. And angle 3 with angle 2, that is our red angle that we've highlighted. I'm loving these highlighters. So that's our red angle that we went and highlighted. What allows us to add or combine two angles together when they're adjacent like this? That's the property we learned back in Unit 1. That's called the angle addition property, or the angle addition postulate. And I've cut that off. The angle addition postulate, P-O-S-T-U-L-A-T-E, and that's really bad writing. All right, so finally, if our angle 1 and angle 2 are the same as AEC, then we're going to make a substitution. We're going to take this angle and we're going to replace what we set up here in this equation. Angle 1 and angle 2 is the same thing as angle AEC. And we're also going to do the same thing on the other side with our angle DEB. That's our angle 3 and angle 2 combo. So we're going to change those two angles to their three-letter names. And we get angle AEC is congruent to angle DEB, which is what we were trying to prove. What was it that we just did? What allows us to put these angles in the spots of angle 1, 2, and 3? That's our substitution property. So we've just proved the conclusion, and Euclid would say QED. Okay, last example. Now this one's kind of like the one we saw just a second ago with the angles, only it's with segments this time. Let's take a look at our given. We're given that the segment WY is congruent to the segment XZ. So let's find that in our picture. We're saying W all the way over to Y. That is congruent to the segment from X all the way over to Z. So from here to here. Those are congruent segments. Our job here is to prove that the segment WX is congruent to the segment YZ. So this little piece here on the end is congruent to this piece over here on the other end. And you can see there's some overlap in the middle, and that's probably what we're going to be dealing with as we go through the proof. So I want you to try these steps on your own. Really pause the video and go step by step with me, but see if you can stay a step ahead of me, best you can. So what do you think the first statement is? If you've noticed already, you should be pretty confident you know the first statement. I'll tell you the reason. It's on your paper. That's given. So what is the given statement? We're going to find it right up here. The given statement is that segment WY is congruent to segment XZ. That should be something you're getting the hang of now. So if these are congruent segments, what does the word congruent mean? What does that tell us? That these are congruent segments. What does congruent mean? Well, it means that their lengths are the same. So let's talk about their measures. Let's say that the length from W to Y is equal to the distance or the length from X to Z. And that is using the definition of the word congruent. But the advantage of it is it gives us an equal sign so we can start putting in numbers and equations. Okay, but we saw again, we referred to congruent here in step 1, and now we are allowed to use it as a reason in our step 2, the definition of congruence. Okay, now let's talk more about the distance of each of these. From W to Y, that's this whole length, but did you notice it's made up of two parts? So let's break it down into its parts. The W to Y segment is made up of adding together the W to X piece plus the plus the X to Y piece. So the little piece here on the end plus this piece in the middle makes the full WY segment. That is using the angle, or the segment in this case, that's using the segment addition postulate. Now the same thing could be said about the other segment in blue, the XZ segment. So give it a try. What would you say XZ is if you're going to break it down into its little parts? X to Z would be from Y to Z combined with X and Y. And maybe you put those in a different order, but adding order doesn't matter. Now I want you to notice something here. I don't have another reason for that because I've grouped those two statements into statement 3 because they have the same justification. You're allowed to do that, or you can list them as two separate statements with copying the reason twice. Okay, now what just happened in the last example is happening here again. We have a WY segment. That distance is repeated right here. WY is equal to this in two pieces. And our XZ segment piece is repeated right here in two parts. So we're going to be allowed to make substitutions. This piece is going to go in for that position, and this, which is equal over here, goes in there. So we're going to recreate making substitutions. We're going to create a new equation, and that is that the WX plus the XY, the pieces added together, are the same thing as the other set of pieces added together, YZ and XY. That's a substitution as we start making trade-offs. Well, do you notice anything? Do you notice anything about this statement that is appearing on both sides? I hope you do. I hope you see that there's this XY piece, and it appears on both the left and on the right. So since it's part of both pieces, both sides of the equation, let's just take it away. Let's do a subtraction. Getting rid of that XY segment, or length, gives us then that WX alone is equal to YZ alone. We did a subtraction as we took off that XY. So you might be a little bit confused about this last step, but we are still supposed to prove that these segments are congruent, and right now we've got them as equal. So if they have equal lengths, can we say they're congruent? And of course we can. The answer to that is yes, indeed. And so we say that they're congruent. What reason do we put? The definition of congruent. Equal lengths mean congruent segments. And there you have it. Over and out.